I'm excited to share with you my favorite tool to use for building language model powered features in my software. Simply put, I think of DSPy framework as an abstraction that simplifies shipping such features. Instead of manual prompt engineering, which is time consuming and brittle, DSPy allows you to simply define modular building blocks just once to enjoy endless flexibility to swap and upgrade them as needed. The highest leverage gain you get when building language model powered features is that your software will automatically improve as better models are released what feels like weekly. However, with manual prompt engineering, there's no guarantee that the prompt or system you've built will work when you plug in the new, better language model. This is essentially what DSPy fix. Let's look at a simple example together to help explain. And the example will first use traditional prompt engineering, we'll set up our configuration with our imports and our API key. And in this example, we're going to classify events, historical events, with these categories. And here we have four categories of wars, politics, science, and culture. Then we're going to specify the model that we're going to be using for classification. And of course, if we can help it, we want to use a cheaper model like GPT-4o Mini. Then we're going to define our baseline manually engineered prompt. And if we want to use any prompting techniques like chain of thought, then we want to define that separately so that we can assess if the prompting technique is improving our results or not contributing, or in some cases even diminishing the results. Then, of course, we're going to need to define how we're going to interact with the language model for the inputs and the outputs, for the baseline prompts versus the chain of thought, introducing a lot of boilerplates into our software. Um, and we want to know how these perform. And setting up metrics is quite cumbersome. So we're going to take a shortcut here and we're going to take a larger language model that's more capable and we're going to have it create a training set for us so that we can run our engineered prompt and any prompting techniques over the training set to help evaluate how they're performing and tweak as needed. So here, once again, we're setting up more prompts so that we can generate this training set. We're then defining how this uh, set is going to be generated. So we're introducing even more boilerplate to loop over each of the categories to have enough of a sample size to have deterministic evaluations. From there, we're going to need some utilities for performing these evaluations, right? So we're going to need to set those up. And then finally, we're going to need to run them and see, well, how did our baseline prompt perform versus how did our prompting technique performed, if there were any improvements. And then once we've done all that, that's just one run, right? We're going to have to go and tweak the prompt that we built and see if the tweaks have made any improvements. And you can get a feel for one, how cumbersome this is, two, how much you're repeating yourself, and we're like 200 lines in. I'm already tired of talking about it, right? And we're gonna have to do this over and over and over and over. Now let's look at the same thing, but using DSPy. With DSPy, we have a modular way to interact with the language model. We're defining the language model and the API key and just configuring, and we're already done. We're off to the races. Then we're going to create our signature. And our signature is a programmatic way of telling the language model exactly what we want. And the way that we do it is very surgically specific on we're going to provide you an event. It's going to be a string. This is your input. And we want a category as the output. And these are the categories that you can provide us, right? And very simple instructions. Categorize the historical event. That's it, right? And then we can do a classification of a baseline using the predict module. Or if we want to use a prompting technique like chain of thought, these are all built in. So we just plug in our signature into the chain of thought module. From there, we just define a success metric, and then we define the larger language model that we're going to use. And for that, our signature is going to be super, super basic. Input is the category, and then output is a synthetic event. And we're going to have DSPy create our training set for us very, very simply. From here, this is where the real magic happens, where DSPy has these optimizers that are very advanced and that leverage a language model to run hundreds, if not thousands, of permutations for us to find the best prompt and the best program that can give us the outputs that we're looking for based upon the train set that we've provided. Here we're using Mi Pro V2, and that's it. And now we have an optimized prompt that we didn't have to use manual prompt engineering, that we didn't have to do vibe checks on. And the system just automatically found the best possible prompt for us, and built out a system, a program that has repeatable results where we know exactly the kind of performance that we're going to get out of it in a little over 40 lines of code instead of 200 plus. That is the power of DSPy, and I think it's revolutionary.